Welcome back to EtherLink AI Insights. I'm Alex, and today we're diving into one of the most exciting and honestly complex shifts happening in enterprise AI right now. We're talking about Agentic AI and multi-agent orchestration, and why 2026 is shaping up to be the year organizations finally move beyond just deploying a big language model and hoping for the best.
Thanks, Alex. And yeah, this is a huge shift. For years, the narrative was deploy ChatGPT scale models and solve everything. But the data tells a completely different story. We're seeing organizations that actually understand how to coordinate multiple specialized agents, each optimized for different tasks, are blowing past their single model competitors by double digits in both efficiency and cost.
So when you say Agentic AI, what exactly do we mean? Because I think a lot of people hear agent and imagine a chatbot that responds to queries. But that's not what we're talking about here, right?
Not even close. Agentic AI systems are autonomous. They perceive their environment, make decisions, take actions toward goals, and do all of that with minimal human intervention. They run continuously, decompose complex problems into subtasks, and adapt their approach based on what actually happens. Think of it less like a search bar and more like a team member who's been given a goal and left to figure out how to achieve it.
That's a fundamentally different mental model. And when you layer in multi-agent orchestration, where you've got several of these specialized agents working together, I imagine the coordination challenge becomes pretty real. Can you walk us through a concrete example of how that would work in practice?
Sure. Imagine a manufacturing company dealing with product defects. Traditionally, you'd have a bunch of manual processes. Engineers examine images, investigate root causes, contact suppliers, generate reports. With multi-agent orchestration, you deploy an image analysis agent, a root cause investigation agent, a supplier communication agent, and a documentation agent. They all operate simultaneously on the same problem, and a coordination layer makes sure no one's duplicating work or stepping on each other's toes. The result? The defect gets resolved faster, more consistently, and with better documentation.
That actually raises an interesting question. Is there data showing that this multi-agent approach actually delivers better ROI than just throwing a massive model at the problem?
Absolutely. Deloitte analyzed over 150 enterprise AI deployments and found that multi-agent workflows achieved 18% better accuracy and 31% lower inference costs compared to single large model approaches. And McKinsey's data shows organizations with agentic workflows reporting 23% higher operational efficiency gains. But here's the nuance. It's not about the size of your model. It's about specialization. Smaller, focused models excel at defined tasks while burning way less compute. That's why the economics work.
31% lower costs is nothing to sneeze at. So if the business case is clear, why aren't we seeing more organizations embrace this today?
Two big reasons. First, it's harder to architect. You need to think about how agents communicate, how they hand off work, how they handle conflicts. Second, and this is huge, there's no clear playbook for evaluating whether your multi-agent system is actually working. Most organizations still think accuracy and call it a day. But agents in production need to be evaluated on task completion rates, latency, cost per workflow, safety, compliance, and adaptability. Those are completely different metrics.
So you're saying traditional machine learning metrics are basically useless for agentic systems?
Not useless, but insufficient. A 95% accuracy score tells you nothing about whether an agent can handle a task without human escalation or whether it actually costs less to run than your current process. In production, you care about task completion rate. Can the agent resolve 85% or more of complex tasks without punting to a human? You care about end-to-end latency and cost per workflow. You care about safety. Are there hallucinations, policy violations, regulatory breaches? And interpretability matters now, especially with EU AI Act coming into play. Regulators want transparency into how decisions are being made.
You mentioned EU AI Act compliance. That's becoming a real constraint for organizations building this stuff, isn't it?
Massively. The EU AI Act creates mandatory documentation and interpretability requirements, especially for high-risk applications. If you're deploying Agentic AI in a sensitive sector, finance, healthcare, hiring, you need to be able to explain why an agent made a decision. That means your multi-agent architecture needs to be designed with compliance in mind from day one, not bolted on afterward. And when you're orchestrating multiple agents, the audit trail becomes exponentially more complex.
Let's talk about some of the building blocks people are using to actually construct these systems. I know RAG, Retrieval Augmented Generation, is a big piece of this. What role does that play?
RAG is context engineering. Instead of relying on an agent's training data, which can be stale or incomplete, RAG lets you inject fresh, relevant information into the agent's decision-making process. In a customer service scenario, an agent might retrieve the latest customer history, account status, and company policies in real time before crafting a response. That dramatically improves both accuracy and reduces hallucinations. The challenge is implementing RAG at production scale. You need robust retrieval pipelines, quality control on your data sources, and evaluation frameworks to make sure the retrieved context is actually helpful.
And there's also this Model Context Protocol, MCP, that seems to be gaining traction. How does that fit into the picture?
MCP is a standardization layer. Think of it as a common language that lets agents talk to different tools and data sources without re-implementing the integration every time. Instead of hard-coding connections to your CRM, database, and email system into each agent, MCP provides a protocol for those integrations. It reduces friction in orchestration and makes it easier to add new specialized agents to your system without rebuilding the entire architecture. It's still early, but we're seeing strong adoption momentum in 2025 and 2026.
So if I'm a CTO or engineering leader sitting in an organization right now, and I'm thinking, okay, we should probably be exploring this, where do you actually start?
Start with an honest assessment of where multi-agent systems would deliver the most value. You're looking for workflows that are either labor-intensive, require coordination across domains, or have clear specialization opportunities. Manufacturing quality, customer support, claims processing, those are canonical examples. Then, before you start building, establish your evaluation framework. Define what success looks like for your use case, task completion rates, cost targets, safety thresholds. Third, evaluate agent SDKs and frameworks, LangChain, Crew AI, and others, but evaluate them against your specific requirements, not just hype. And fourth, start small. Build a pilot with 1 or 2 agents, prove the concept, measure actual ROI, then scale.
I like the emphasis on starting with evaluation frameworks and success metrics before you build. I imagine a lot of organizations are tempted to jump straight to, let's use this new tool without thinking through the hard part, which is, how will we know if it's actually working?
That's exactly the mistake we see. Organizations end up deploying multi-agent systems. They look good in demos, but 6 months in, no one actually knows whether they're saving money or improving outcomes. You establish your metrics up front, you baseline your current process, and then you measure relentlessly. That's how you either course correct early or scale with confidence.
Let's talk about cost optimization, because that 31% efficiency gain we mentioned earlier is compelling, but I imagine there's a real art to actually achieving it. What are the levers?
Model selection is huge. You don't need a 70 billion parameter model for every task. You might use a large model for complex reasoning, a smaller model for classification, an even smaller model for simple lookups. That alone cuts costs dramatically. Second, prompt engineering and instruction tuning. Well-designed prompts reduce token usage and error rates. Third, caching and retrieval optimization. If you're calling APIs repeatedly, batching and caching results saves money. And fourth, failover strategies. Sometimes the cheapest path is having multiple agents with different cost accuracy trade-offs and routing requests intelligently. It's not magic, it's deliberate architecture.
So it sounds like getting to production Agentic AI requires pretty solid engineering discipline. It's not just about model quality.
Not at all. The model is maybe 40% of the problem. The other 60% is orchestration, evaluation, cost management, compliance, and operational stability. You need people who understand distributed systems, data engineering, and ML ops. This isn't a ChatGPT plugin anymore, it's real infrastructure.
Final question. If we're in 2026 now and organizations haven't started on this yet, are they in trouble?
They're not in catastrophic trouble, but they're leaving significant ROI on the table. Every quarter that passes, first movers are refining their orchestration strategies, getting better at cost management, building compliance muscle. By 2027, 2028, the gap between organizations that got early experience and those just starting will be really noticeable. So the time to start exploring is now, even if it's just pilots and learning.
Great stuff, Sam. For everyone listening who wants to dig deeper into this, agent evaluation frameworks, MCP integration, RAG production systems, the whole picture, head over to EtherLink AI and find the full blog post on Agentic AI and multi-agent orchestration, enterprise ROI in 2026. It's comprehensive, it's practical, and it'll give you the foundation to start thinking about how this applies to your organization. Thanks for listening to EtherLink AI Insights. We'll see you next time.
Thanks, Alex. Great conversation.